Hi, everyone. Thank you so much for joining us along with N2WS and SpotInst. So we have a lot to cover today, so we're going to get started. So today's topic is AWS Cloud Resilience and Container Workload Automation. And you're certainly in the right place if you're an organization using or transitioning to AWS, particularly if you're using EC2. So we're really excited to share the great tools that we have to help you with your cloud automation. Okay, so our agenda today will cover tips on how to automate your AWS workload for backup recovery, as well as other great time and cost-saving automation tips. And we'll follow that up with a live demo of how N2WS works. And this will include a really special sneak peek at our upcoming version 2.7, which is coming out in just a few days now. Then SpotInst will cover their great tips for container workload automation and resilience. And we'll see a live demo of how that works. And please don't forget to type in any questions throughout the webinar, and we'll get to those at the end of the presentation. So presenting today, we have two really special guests and cloud experts. Sebastian Straub is one of N2WS's top sys engineers and AWS/N2WS expert. He has over 20 years of experience in security and backup in the cloud, with previous, to name a few. And we have Joey Yep on the SpotInst side, who brings over 20 years of expertise as a cloud solutions evangelist. He has a lot of experience in large data center design, deployment, SaaS cloud solutions. He also has numerous degrees and certifications in companies such as ZeroStack and Broadcom. Okay, so before I hand it over to the presenters, I just would love to get, we would love to get a poll going. So this is a live poll, and you should be able to see it. We just love to know if your organization's data is currently on the public cloud, and if so, which cloud, or perhaps it's more than one. And so we will reveal the results of that as soon as those votes start coming in. Okay, great. So while you guys are voting, Sebastian, I'm going to hand it over to you.
Oh, wait. Thank you very much, Jessica. So it's great to be here, and so let's get started. The AWS Shared Responsibility Model. This isn't a secret or anything. AWS posts it on their website. It's one of the things you click away real quick when you sign up for AWS. And they provide the virtual hardware, and they'll do their best to protect that virtual hardware. But whatever is running on and in that virtual hardware, that's still your responsibility. The content, the data, is something that you must maintain and protect. So why we still need backup and recovery in AWS? It's the cloud, right? And as we just talked about, because of the shared responsibility model, the infrastructure itself is safe. But the data that you're storing within it, that's still at risk. It's a brave new world and everything is in the cloud, but the reality is, as far as your data is concerned, really nothing has changed. You still need to protect your data. EBS failure. Did you know that EBS volumes have failure built in? Amazon even posts this on their website. EBS volumes are designed for an annual failure rate of anywhere between 0.1 and 0.2%. That's really reliable. It's about 20 times more reliable than typical on-prem disk drives. But it also means that if you do the math, and if you're running 1,000 EBS volumes, you will lose one or two of them a year. And the worst part is you don't get to pick which two. Probably isn't going to be the volume with the cat pictures. It'll probably be the volume with the customer database or the only copy of your most recent project. And then, of course, also ransomware. Just 2 days ago, 3 U.S. hospitals and 7 Australian hospitals were hit with a ransomware attack, which meant they had to turn away patients. And their infrastructure was just simply shut down. Or 2 days before that, did you hear about the largest hearing aid manufacturer in the world? They announced that they were hit by ransomware 6 weeks ago, and they're still recovering from that outage, and they're estimating that it will cost them $95 million. And this just goes to probably fast. And of course, compliance and data security. You probably have to follow compliance regulations that don't care where your data is stored. You need to be able to prove you're backing it up. An AZ failure. Remember Labor Day? AWS had a long outage that took almost all day to recover from. And some volumes never came back. And of course, also human error, right? What's the worst sound you can imagine in IT? I would say it's uh-oh or oops. How easy is it to delete content in AWS accidentally? If you ask me, far too easy. So at this point, you're probably thinking, wow, that's pretty bleak. But you're probably also thinking that I might have an idea what to do. And of course, right you are. So N2WS Backup and Recovery is the market-leading backup solution for AWS. It's purpose-built native to AWS. Backup solution which allows you to take complete control of your backups, recoveries, and archives in an easy-to-learn graphical user interface. And again, this isn't rocket science. There's no scripting, no archaic, weird process to follow. It provides flexible policies and schedules, long-term archival of the data into S3, and almost near instant recovery from any type of outage or failure, and probably most importantly, a single pane of glass. I don't have to go hunting for my backups across AWS accounts and regions, one single console for everything. One ring to bind them, and also one console to find them. So flexible retention options. How about creating backups every 5 minutes during business hours? But if something really terrible happens, I can always turn back time and be back in business. On the other hand, let's fall back on backups every 8 hours outside business hours. And also different storage tiers. Utilize whichever storage tier and retention makes sense for you, and only retain the data that you want to keep. Now, volumes versus VMs. Why make life harder on yourself and only backup volumes? Many times I speak to companies that are in the cloud and they think that backing up volumes is a viable backup. That's just a hard drive laying on your table. You're missing what makes it a server, the entire instance, the metadata, the VPC settings, subnet, routing tables, security groups. Flexible recovery options, and I'll be talking about that a bit more in a moment. Restore anything, let's face it. Disasters come in all shapes and sizes. It might be your entire environment, your instance, or just a volume, but more often than not, it'll be someone who says, can you bring back that really important config file, that super important Excel sheet or PowerPoint? You know exactly who I'm talking about, and you all know that guy. Multi-tenancy. Now, you can manage any number of AWS accounts from one single console, and you can put up virtual fences around the content. You decide who gets to see what and what they can do with it. And really important if you're a managed service provider and you would like to offer this as a service to your clients. I love this slide. The promise of the cloud finally delivered. So on the left side of the screen, you can see what AWS provides you with. The AWS Snapshots, very fast, very efficient. APIs, which open up the service, durable storage, which is much better than anything physical, then Lambda scripting, and of course, a multitude of regions and availability zones. Now the puzzle gets completed with what you're seeing on the right side of the screen. This is how N2WS makes this a breeze for you. Simple and easy to learn UI. You'll be an expert in this in about 30 minutes. VPC backup will not only back up the content, but also the infrastructure that goes along with it, all the network settings. And of course, archive for long-term archival into the much cheaper real S3 buckets. Complete auditing, reporting, and alerting, and of course also application consistent backup of your databases, Exchange, you name it. Anything that you want to make sure that each and every transaction counts. A little bit about us. We were founded in 2012. Version 2 of our software came out in 2013, because that's 6 years ago. We are certainly not a fly-by-night operation. We are the #1 rated backup and recovery solution in the AWS Marketplace. We're purpose-built for AWS, no compromises. And it's also easily distributed via the AWS Marketplace. Pre-configured, you just spin it up in your environment. And we are a global trusted partner across all the verticals: banking, healthcare, higher learning, And of course, we're a preferred partner of managed service providers. We enable you to be the hero for your clients. And we currently protect more than 5,000 AWS accounts, hundreds of thousands of instances. I think the last count was a tick over 200,000. And our solution protects a grand total of more than 13 petabytes. Now, to give you an idea what a petabyte is, and all the pictures combined stored on Facebook are approximately 1.5 petabytes. And I certainly know my wife is probably responsible for about 10% of that. All right, so I think we're going to go to another poll. How are you currently backing up your AWS environment? And you're just going to go ahead and make that choice while we go through the slides that we have left. So let's talk a little bit about how we really make sure you're covered in every conceivable situation. Cross-region backup. Remember the days when you had to take your backup tapes off-site? Perhaps at the end of the day, someone came and picked them up, and those days are over. You can move mountains with 3 mouse clicks. Why is this important? Well, regions aren't invulnerable. They do go down. Most recently, as I mentioned earlier, during Labor Day. So for those cases, it's best to have a fallback copy available in another region, perhaps even on another continent, so you can spin up your content anywhere else you would like. Cross-account. Now, why would I want to transfer my backups into another separate AWS account? If you want to sleep well tonight, don't do what I'm going to tell you next. Do not Google the words code spaces. CodeSpaces is a company which went out of business within 24 hours. They did all the right things. They performed backups, they performed cross-region backups, but they didn't perform cross-account backups. Then one day they were hacked and the hacker sent them a ransom note. They said, we won't pay, and the hacker said, well, then I'm just going to delete everything. He literally deleted the entire company. There was nothing to fall back onto. It could have been so easily prevented with N2WS. That's simply just 2 mouse clicks. So then, of course, let's combine into one, and you have a virtual Iron Man armor around your environment. Cross-region, cross-account gives you the complete safety package and the fastest possible RPO and RTO. Let's talk about cost. Let's face it, backups are a necessary evil. It's like car insurance. Show me someone who says, I love paying car insurance, and I'll show you a crazy person. Well, when you get into an accident, it's really nice to have. And that's when you start talking to geckos, and you're really happy when you can save 10% or more on your car insurance. So the AWS cloud isn't any different. But how does more than 50% savings sound? When you need to retain your backups for a longer amount of time, 30 days, 60 days, 7 years, or even longer, recovering your workloads in 30 seconds sounds great, doesn't it? But do all of my backups have to be in the kind of expensive snapshots? Nobody's going to cry if my recovery of a workload from last March will take 5 minutes instead of 30 seconds. So why not use a cheaper tier of storage for archiving? Something else that will save you money is start and stop of instances. A few months ago, I read an article which said that it's estimated that the industry will waste $14 billion this year on cloud waste, resources that are on doing nothing when they aren't needed. And I'm going to go out on a limb here and say that not all instances in your environment have to be up and running 24 hours a day, right? So why not tell N2WS which ones can be shut down, for example, at nighttime, and we'll turn them back on whenever you need them. And if you need any more reason to think about archiving into S3, did you know that S3 has a higher durability and higher availability than EBS? So it's cheaper and safer. Gosh, sign me up, right? Now with this virtual light switch for your instances and resources, you can even use hibernation if you'd like. It works just like the light switch in your office. Turn it off when you don't need it, and that will help you save a tremendous amount of money on your EC2 runtime cost. Savings up to 60% is easily achievable. And also, you don't need to learn Lambda scripting and CloudFormation. N2WS will do the heavy lifting for you. It will automatically monitor for changes in your configuration. You know how it goes. Someone makes a quick change to a security group that just to make something work, and that change might go unnoticed, might go undocumented. Well, no more. AWS will see this change and it will capture that so that I can then rebuild the configuration anywhere, anytime. There's a multitude of every conceivable report you could ever want. And the best part is you can schedule these reports. Would you like to review your backup usage over the course of, let's say, a week? No problem. They will get emailed out on Monday, Friday, or whenever you'd like. Would you like to give your customers the ability to receive daily backup reports? Also, no problem at all. Now, let's talk a little bit about a few AWS options that will save you money. Okay, so let's say you're in AWS now and you're quite happy. You have a multitude of instances running and you're paying a premium every month for that. Did you know that you can lower your instance costs even further? If you're ready to make a real commitment to AWS and commit to up to a 3-year contract, you could save anywhere from 25% to more than 60% on instance cost. And AWS even provides a nice service called the AWS Trusted Advisor, which will automate the data collection. It could then advise you on what's the best contract terms for your specific environment. And this is the part where we say, oh, wait, there's more. Spot instances are instances that aren't being used right now. And AWS essentially has a surplus of resources, and as nice as they are, they're willing to let you use them for a steep discount until they need them back. And then AWS will take them back. And those spot instances can be had with a 70 to 80% discount. The only problem is, it's always a problem, right, that termination notice only gives you 2-minute warning. But on the other hand, luckily, AWS can help you with that because you can actually create backup schedules as flexible as 1 minute. All right, so to recap, there are plenty of options: spot instances, on-demand instances, reserved instances, and you choose between them to really maximize your savings. So no matter which route you take, AWS will make sure that your data is protected. All right, so now this is where we're going to get into the demo, because we all know words are cheap. And let's actually see how this works in real life. All right, I'm going to go ahead and share my screen. Now, that's the AWS Marketplace. As I mentioned, that's how the system is deployed. It's just a virtual appliance. You just choose in the AWS Marketplace. It spins up as another EC2 instance in your environment. Also very important, it's very, very lean. It only requires a T2 small instance. So once it's spun up, it can be accessed through a web portal, and that's what that looks like. Now you have this blue band up here with the different tabs: Backup Monitor. That's your single pane of glass. That's going to allow you to see all of the backups we've performed across all different regions, across all different accounts. And of course, I can start filtering this down any way I see fit. Policies and schedules. Don't worry, I'm not going to bore you by showing you how to create schedules, but let's take a look at the policies, because that's where you decide what you would like to back up. You're in complete control of how often would you like to back up something, how long would you like to retain this, and then, of course, you can also choose, well, what exactly do I want to back up? And that's done over here in the backup targets. So here you can see what I'm already backing up, and I can add instances, and that includes everything. So all the metadata, the VPC settings, the subnet settings, everything I need to recover this entire instance. It works like your brain, because when you're thinking servers, I would bet that you're thinking entire entities. Hardly anybody thinks particular volumes. But gosh, if you really want to do this to yourself, you do have that option. So we also have the option to back up only volumes, RDS databases, Aurora clusters, Redshift clusters, DynamoDB tables, and also Elastic File System, EFS. Now, when you want to add something, it's just a graphical user interface. Just click on it and choose what you'd like to back up. Click Add Selected, and that's really all there is to it. Now, you also have the option to perform that cross-region backup, and I'll show you how that's done. It's right here next to it. It's that DR button. So here I can choose, well, every time you perform a backup, I also want you to perform a backup of the data into another region. This can also be multiples, and perhaps even into another account. That's that cross-account disaster recovery, Just hint, hint, that code space is disaster. That's not going to happen to you when you perform that. All right, we do have the option to perform application-consistent backups on Windows instances and also on Linux instances as well. Now, let's actually perform a recovery because, well, that's really our claim to fame, and I've told you recovery is very fast. So let's use that single pane of glass. I'm going to click on Recover, and we have different options here. So I can recover into a different region, into a different account, and I can even choose to recover from an entirely different account if I wanted to. I do have the option to recover the entire instance, particular volumes, and also file and folder level. So let's do a recovery of just an instance. I'm going to go to Options, and because in my case my instance is still up and running, so I don't want to cause an IP conflict, so what I'm going to do is I'm just going to blank this so that AWS is allowed to assign a new IP address to it. And down here, that's my recover instance. It's going to say, sure you want to do this live right now? Sure, why not? What's the worst that can happen, right? Let's find out. All right, there we go. Operation succeeded, and one instance was launched. Now, if we're quick enough, I can actually show you what that looks like in my EC2 console. All I have to do is just simply refresh this, and there it is. It's currently spinning up. It's still in pending, and it's probably going to stay like that for another 10, 20 seconds or so. Now, the moment this button here turns green, that instance will be fully functional, which means I didn't have to start figuring out which volumes go along with this instance and how do I reconnect them and all of that. It was really, really easy. Now, of course, the moment this button here turns green, that instance is fully functional. It's almost like I timed it. Now, the recovery of an instance, of course, is largely dependent on the size of the instance. But we've done some extensive testing with this tool, and we have the ability to recover a 14 terabyte database instance in about 3.5 minutes. We're truly the fastest solution out there. There's nothing faster. Now, you do have the ability to manage multiple AWS accounts in a single console. That's done right here. Now, I do have the option to perform cross-account backups. And as I mentioned, if I do want to do a recovery of just particular folders and files, I can do that as well. That's what that looks like. Now I can browse through the data and recover only the data that I actually need. And this just happens to be a Windows file server, but it really doesn't matter at all because N2WS is completely OS agnostic. Doesn't care if it's Windows, doesn't care if it's Linux, doesn't even care if the data is encrypted because we do have the ability to actually back up encrypted data across regions and cross accounts without the end user having to worry about the KMS encryption keys. You do have the option also to use users. You get to choose what they're allowed to see and do, and everything comes with detailed reporting. This is per user, but of course you can do the same thing for the entire user population. You'll find those reports down here. If you wanted to find out everything we're not backing up, well, that's the unprotected resources report. And you can also inverse that question. Well, show me everything we are backing up. That's protected resources. Now, we also have the option to trigger alerts, of course. And then at that point, this is usually when customers say, well, help me save money. And that's what the S3 repositories are for. So up here, you just simply get to choose which S3 buckets we are allowed to use. And then within the policies, you get to choose how you would like that data to be archived. So that works then simply like this. I can choose how long I want to retain the data in S3, and I even have the option to choose my storage tiering. So I can put this into standard S3, infrequent access, and even intelligent tiering. So that is really convenient because that's going to save you quite a bit of money. And then also the resource control, that allows you to actually turn instances on and off however you need them. It's done very easy. So I created a group called All Non-Essentials. Here I can choose instances and databases that don't need to be running 24 hours a day. Next to that, I have an on and off schedule, and I can say, well, at nighttime, I want you to turn off, and in the morning, I want you to come back on, and on the weekend, I don't need you either. Again, this is going to save you anywhere between 60 and 65% in EC2 runtime costs because the instances are only up and running during business hours. And absolutely everything I've done now can also be automated as well. You don't actually have to do all of this manually through the policies. See, in the EC2 console, we have a custom tag called CPM Backup. And the same thing for the resource control. So that means the moment you start up an instance, we will immediately make sure that that instance will get backed up, and we also have the option to then decide when we're going to turn off that instance and when we're going to turn it back on. So that's a super high-level overview of the solution, how it works, how it's configured, but now you actually saw how this entire solution works. All right, so now this is the part where I'm going to hand it over to Joey. I know you have something really interesting to tell the audience as well.
That's right. Thank you, Sebastian. And wow, I get to follow that. Sebastian, you've got that perfect presenting voice, cadence, and soothing accent. I think I could listen to that all day long. I hope I can maintain that level of quality as we move forward here. Well, greetings all.
You know you will.
Thank you. Appreciate it. Well, greetings, everyone. I'm Joey Yep, a solutions architect here at SpotInst. I'm going to speak a little bit about the challenges that we face ensuring workloads that run uninterrupted and always are matched with the appropriate right size and cost-optimized infrastructure resources. And we'll take a little look at the value of automating AWS workloads and improve the efficiency, including how to reduce operational overhead and hopefully even some development time as well. But before I really get started and get too far, I'd really like to take a quick poll regarding Spot instances, also known as preemptible VMs in GCP or low priority VMs in Azure. Just want to take a look at how many of you are currently using Spot instances today and at what level of workload. So Jessica's going to launch a poll if it isn't already. We'll take a look at those results as they come in. Let's see. This one is live now. So I'll give it a little moment as those results come in. Spots were mentioned briefly by Sebastian. That is a great way for users to really take advantage of some cost savings, but they do have some caveats to them, which I'll speak a little bit more about in depth in just a moment. So as we're coming in here, it looks like most are actually, looks a pretty decent spread now that the results are slowly coming in. So it looks like some of you will learn a little bit about Spot instances today, haven't been aware of them before. Maybe for the others, you'll see something today that might be able to help you automate your current workloads and push them forward. Looks like a pretty decent spread. Some are using them, but primarily for dev and test workloads. I hope you all can see those results as they're coming in. They're quite a nice spread. Not too many of you, if any, are using them in production now. So hopefully you gave some confidence today as we move forward. So just a really quick level set. So I go a little bit deeper than what Sebastian mentioned about Spots. These are the excess resource capacity that cloud providers have ready today, on standby, waiting for customers to spin up the normal on-demand resources. So they can launch and grow their public infrastructure as they need to. The cloud providers have very large data centers, as we all know, but much of them are running just idle, sitting there, waiting to deliver these infrastructure for these instances, but they're empowered on, taking cooling, pretty pricey to keep those running. But in order for them to try to utilize these resources better and to recoup some of those costs of keeping them idle, they offer them at very steep discounts, as much as 90% off the on-demand rate. They also come with those caveats that we mentioned before. They don't offer availability guarantees on these types of instances, and they can take them back with as little as a 2-minute notification in AWS, like Sebastian mentioned, but even lower, just a 30-second notification in GCP. This really pigeonholed Spot instances to being useful primarily for dev test, cloud-native, stateless type workloads, but made most enterprises really wary to use those in production. That's where SpotInst comes in. We've identified this need to help automate and use Spot instances to take advantage of the cost savings. And we've used a prediction algorithm, and with these capabilities, we're able to gracefully replace Spot instances and the workloads running on them to enable Spots for more production level workloads. Pardon me. This is the concept that really allowed SpotInst to be founded, 2015. So just a little bit about us. We've raised significant amounts of funding with a goal to optimize that infrastructure for our customers in the most efficient way, both reducing the costs and footprints as well as automating the operational work in addition. So we currently have about 150 employees spread across 4 different countries, 4 different locations: San Francisco, New York, London, Tel Aviv, and we're in about approximately 1,500 customers. We've had really great success with this. We're growing significantly. We're managing now about 3 billion excess capacity resource hours per month. This is truly helping our customers reduce their public cloud costs, on average somewhere between 60 and 80%, by way of leveraging these spot instances and reducing the overall footprint due to some of the more efficient ways that we're able to automate and deploy their workloads. We offer a simple pay-as-you-go model, so just charging a small percentage of the savings we generate over the normal on-demand pricing. We're currently trusted across the board from all of customers of all different sizes and shapes. Some of these customers have thousands of instances that we're managing, others just a handful. We're accessible worldwide and are currently deployed in over 50 countries. So I won't bore you too long with that. So now I'm going to get into some of the challenges that we're facing with managing and operating containerized workflows and environments, generally speaking, in the public cloud. So how we can really help alleviate these issues through automation and added benefit of significant cost savings. Then I'll run through a real quick demo and how we address these. So in the perfect world, we'd like to be able to deploy container requests of all different shapes, sizes, different resource requirements, constraints, without having to actively think about the infrastructure and whether or not it's being efficiently used. Like playing the old game of Tetris, as you see here, filling up the infrastructure in the most efficient way. We need to automate the decision process and eliminate waste to maximize that workload agility, as well as save on our cloud spend. But of course, it's not that simple. So when we start looking at the container orchestration layer, so one challenge is how to appropriately handle the deployment of containers that come in all these different sizes. Different shapes, they have their own requirements in terms of vCPU and RAM. But we need to really look at these with their own set of defined requirements to adequately service these incoming requests. Then we have to couple that with the similar challenges faced in identifying and deploying the infrastructure. So we can look at all those different requirements and see if we can't actually match those varied needs. Couple that even further with some concepts around how we can actually achieve this in both layers. So some of these have already been defined, attempting to address these like vertical pod scaling or VPA, that looks at the redeploying the containers with either more or less vCPU or RAM, for example. But this traditionally requires the container to go offline, essentially rebooting it to take advantage of the newly defined resource definitions and requests. So that leads us to a more often chosen path of doing horizontal pod autoscaling, or HPA, that sets thresholds for container resource utilization, or steps up the number of replicas, and for that given microservice. With similar thresholds, mind you, these are separately managed, defined in the infrastructure, with the added concept of planning for headroom, where you should have enough idle resources available so that newly launched or scaled out containers will have a place to be scheduled immediately. So these traditionally metrics-based skep scaling policies and the headroom planning challenges have a significant time lag, essentially, and especially when considering container to node placement requirements, like node selector labels, taints, tolerations, everything around the types of nodes, be they spot or on demand. Maybe they require GPU. Too often we're seeing that traditional scalers like this, these step scaling pieces, leave containers left in the unscheduled or pending state due to some kind of mismatch in the infrastructure. Or at the other end of the spectrum, there's too many wasted resources waiting for containers to be defined and to be launched, unnecessarily cranking up those cloud costs. So challenges in right sizing, as always, it doesn't just stop there. There's the full life cycle to take into account. Looking at these red containers here on the screen, how they've grown, they may have shrunk. How do the requirements actually change over time? Were the originally guesstimated estimates of the vCPU and RAM adequate? Were they too much? Do we need to actually go back and actually change the definitions and relaunch them? To consider all of these different options and variables, it really starts to add up in the management overhead arena. We really need a better way to automate. We find that interesting, you may find it interesting actually, that the container orchestration platform Kubernetes was originally based on Google's platform called Borg. Borg was actually designed as a fixed size infrastructure. It didn't have that concept of an elastic infrastructure that we use today in the public cloud. It's certainly come a long way since then, and we do have some available resources and solutions for you. Enter SpotInst. So SpotInst offers a SaaS platform that optimizes that cloud infrastructure through cost automation, abstract complexity, and provides that multi-cloud management. You give us permissions to manage some specific resources inside your cloud account, and SpotInst, and then instead of creating those inside your AWS directly, we'll create those for you using the API. You can do that through the API console, through automation, through infrastructure as code like Terraform, CloudFormation, Ansible, whatever deployment tools you might choose. This allows us to manage your infrastructure and make sure that we help you reduce those costs and make your administration life a lot easier. So SpotInst currently offers 3 main products: Elastigroup for provisioning, managing, and scaling the cloud infrastructure itself, while Ocean, built on top of Elastigroup, is really an abstraction layer that creates that serverless experience for containerized workloads, offering low-level insights into what's actually happening, like container placement, cost chargebacks, as well as additional automation for container environments themselves. And finally, our most recent add is Eco, a managed service for procuring, selling, managing your RIs and making sure they match up for what you're actually using versus what you have committed to in your billing. So this further reduces your cloud spend and makes more efficiencies on your long-term running workloads. So really quickly, I want to take a look at that first product, SpotInst Elastigroup. So looking at this, it really helps with the automation by incorporating our own autoscaler, leveraging a SpotInst controller inside your clustered environment for containers that monitors the container requirements themselves that you're launching in your pods and your workloads. So as the containers themselves scale, new ones being added or additional replicas being created, we are, rather than doing normal step scaling that we mentioned before, SpotInst takes that aggregated look at the requested resources by all the containers and deploys an infrastructure that intelligently matches and bin packs the differently sized containers at the same time, not waiting for those step scaling thresholds to actually kick off. So this drastically cuts down on the amount of time that containers are left in that pending state. So similarly to how N2WS handles too many resources, like Sebastian mentioned with the virtual light switch, we have the ability to turn off and on idle resources. We can programmatically schedule capacity changes, including 0 even, so turning everything off until it's needed. This is useful in dev test, especially, for example, scaling in when developers are at home at night or on weekends, and scaling back out when heavy testing is ready to be done. This can achieve significant savings throughout just simple automation. To address the resiliency aspect of things, SpotInst uses predictive algorithms to gracefully replace instances up to 20 minutes in advance, more than just the 2-minute notification you get. So this would be before the interruption by the cloud provider, thereby maintaining high availability of the containers and the services that they're running. For Spot instances, we monitor and predict when the provider might repossess that instance, spinning up a replacement, cordoning it off, draining the existing workloads that are running on there, rescheduling that to the remaining cluster, and making sure that everything's up and running. For normal on-demand instances or reserved instances that you have running, we monitor their health, make sure that if they do go unhealthy, that we replace those in a graceful manner. And this way we are able to tolerate failures and interruptions on that infrastructure layer. Jumping ahead now to Ocean. So built again on top of Elastic Group, taking advantage of its autoscaler and its ability to handle the infrastructure, Ocean takes advantage of the pod-driven scaling and performs that abstraction layer between you and that infrastructure. So Ocean really provides that serverless experience by making the infrastructure decisions for you. So no VMs for you to have to manage, taking away that overhead. It also provides really deep insight into the cluster, it reports cost, resource used by each container deployment. It's got additional intelligence built in to automate the functions of headroom and launch specifications. We can do all that within a single cluster. You're no longer having to manage multiple auto-scaling groups per cluster for specific launch specifications. So we're completely aware of all the different labels and even persistent volumes within Kubernetes. We're able to handle those. It also monitors the containers over time to make suggestions to resize the definitions according to the real-world utilization, helping to further achieve that bin packing efficiency. For example, we had a customer that originally was running a very, very large individual Kubernetes cluster, had over 11,000 cores in the cluster. To put this in perspective, they were running about 1,400 M4 2XLs that cost about $800,000 a month. But after shifting to SpotInst, using our Kubernetes autoscaler, they were able to immediately scale down the total number of nodes by about 40%, just by better bin packing. So it just cut down the number. So we're defragmenting, right-sizing, and bin packing those containers in a more efficient and more intelligent way. And this was even before thinking about using Spot instances to further save on the cloud spend. So now, leveraging the Spot instances and reducing their footprint, we're using a variety of instance types and sizes to better match the workloads that are there. Their monthly cost went down from $800,000 to $90,000. This is a massive reduction from 11,000 cores down to about 6,000 cores. Pretty significant savings that we're able to do, just automating and more intelligently working the infrastructure. So just a real quick note on the overall stack of solutions. So we offer integration with existing container orchestration tooling like Docker Swarm, Kubernetes, EKS or ECS, and the AWS. Lots of acronyms there. Alphabet soup, right? These work directly with Elastic Group layer, so you can layer on top Ocean as well as that to take even further advantage of our bin packing. So putting it all together, well, we talked about approaching better efficiencies in cloud management in really 3 layers. Seeing how we can leverage Spot instances in addition to on-demand and even reserves. I'll show you a quick demo on how we've matched the correct instance sizes and types to the demands of the containers themselves, and how we look at the full life cycle of microservices to better define the real-world requirements rather than having to guesstimate and really truly maximize the cluster efficiency. So with that, I'll jump over to a quick demo. One moment. All right, you'll be seeing my SpotInst console here. So this is the main landing dashboard for an Elastic Group account. With this, it's just going to show you the total number of Spot instances that we're managing inside the account, the total potential cost, so what it would have cost for you to run these, all the different instance types and sizes for the amount of hours they're running, run those as on demand at the current market rates. Then we give you the actual Spot costs that because we're leveraging those Spot instances and their market rate there, you'll see the amount saved and the total percentage that we're saving against that on-demand resource market rate. It also shows that we do also have the capability of managing on-demand resources. Depending on the type of workload you have, you might have some databases, et cetera, that might need to be always running on demand and can't handle the service interruption of a Spot instance. Those we can manage as well and automate. We have that capability of also running those in RI, so matching up the billing capabilities on the back end to really help take cost efficiencies into account. Looking down, just looking at overall resources in your account in AWS explicitly, we do have the ability to attach to GCP as well as Azure. We have the capabilities to across the board for multi-cloud. We saw some of those poll results before. So here we have the ability to look at reserved instances across your account, those that might be even vacant. So we'll take advantage of those before launching additional on-demand or additional spot instances, trying to keep down your overall cloud costs. With that, jumping into the Elastic groups, just want to talk real quick about some of the native integrations that we have in those public cloud providers. So as an example here in AWS, we can directly integrate into many of the services that they provide. So generic auto-scaling groups, load balancers, even Beanstalk, jumping into containerized workflows for Kubernetes or ECS, even Fargate. We can help to manage that and reduce some of the costs there by leveraging spot instances behind the scenes instead of using Fargate. Some of the other managed container orchestrators as well. So all of these do directly integrate with the Elastic Group, and we can immediately start taking advantage of the automation and workflow intelligence that we have built in. On top of this, we can layer Ocean for the containerized workloads. So those Elastic groups that you define with Kubernetes, either COPS directly into EC2, or if you're leveraging EKS as the management layer, we can provide Ocean as a layer on top of that to help really abstract a lot of the administrative overhead that you might be experiencing now. Jumping into one of our Ocean clusters here, we get a direct look at the costs that are associated with this particular cluster. We can see what kind of direct information feedback from the cluster itself, giving you some of that insight in terms of what version of Kubernetes we're running, the number of nodes, the pods that are active inside the cluster. Look at the CPU and memory allocation to the nodes and infrastructure itself. This does take into account that headroom that we have available, which is configurable by yourselves to really customize what kind of workloads you're running and make sure that you're satisfying those services. Have a deep look into, we break this down in a nice orderly fashion for the namespaces and each deployment they actually have. You'll see that this particular deployment, the total number of resource utilization inside the cluster, its costs associated with that, applying that back to the SpotInst hours and things like that that are running, breaking it down even to the headroom. Full capabilities of reporting this. You can pull this information out with APIs, directly put it into some of your reporting tools so you can maintain trending analysis and everything going on. We also have the ability to, like I mentioned before, look at time series of data over the lifetime of the pods that are running. And we'll look at the definitions of what they have running versus the requests that are running versus what they're actually using over time. So we'll see here that this particular one has defined to use 0.1 vCPU per container and 200 megs of memory. But in reality, over time, it's actually using a little bit more vCPU and a little less RAM. So we could really tune in a finite manner to really take advantage of the efficiencies of bin packing these containers, getting them right-sized and appropriately put out there. Have a quick look at the infrastructure as we're controlling it. So as that serverless experience, we're looking at all of the pod recommendations or requests, pardon me, so all their vCPU, memory, if they need a GPU or not, do they need to run it on demand? We're taking all that information into account, and we're launching the infrastructure to match and to get great utilization resources versus what's actually being used by the containers themselves. So as you see here, we have a very varied mix of instance types and sizes. So M4s, R4s, 16XLs, 10XLs, mediums, etc. Just to look at really maintaining that difference in how pods can be defined. We're looking at some that are on demand, leveraging reserved instances, and many of these are just running on spots. Containers being that native stateless workload that can handle and being rescheduled into the infrastructure. We are constantly doing what we call simulated bin packing, looking at the overall architecture of the infrastructure, seeing where pods are deployed, and seeing if there's actually a simulated way where we could better bin pack those even yet further. So even those that are currently existed and scheduled, we're looking at see if we can rearrange those in even more efficient ways so that we can have better utilization of the infrastructure. completely shrinking that overall footprint in the cloud, as well as having maximum utilization of the nodes that you are running. In our fully logged infrastructure as to what's going on, so you can get full insight as to the activities that are happening. For example, when we scale down, we'll see that we're detaching these particular instances. You can pop up the details here to see the pre-scale event, overall cluster size, what it will look like after the fact, and see which individual nodes that we're actually taking down, and see how they're, what pods are finishing and what's being rescheduled, and which instances we're actually scaling back. And on the converse of that, we can look at those that are scaling up. See if I can find one in here. See, we have just one instance here being launched. Usually we'll have a particular set of requirements across the pods that are being requested to be scheduled. We'll look at that, take that into account, and then appropriately match that. And in this instance, we'll also look at other containers that are launched and see if we can put those together. Also taking into account headroom. So this one in particular is looking at making sure that there is enough space for containers that are going to be scheduled to be landed onto an infrastructure node immediately without having to wait for that process to be spun up. That's a real quick high-level take into what SpotInst can do for automating and more intelligently managing your infrastructure for your workloads. Primarily we looked at the containerized workloads and how it can significantly reduce not only the footprint, but also your cloud costs, taking significant advantage of those SpotInst discounts. At that point, finishing up on that demo, open it up for some questions from the audience if we have any in the feedback.
Cool, great. Thank you so much, guys. And just, I can attest that both of you have very meditative webcast voices. I really, really enjoyed listening to both of you. So that's just my opinion.
Thank you.
Okay, so we have a few questions for both presenters. Okay, Joey, this one's for you. Does SpotInst provide better visibility over AWS native Kubernetes services?
It does, as I somewhat showed there in the demonstration there. We do have deep insight into not only what infrastructure is matching to which individual pod determination and deployment, we also show the individual costings and metrics around each of those deployments. So you can really get a handle on not only how the deployments of those pods are scaling into the environment, how their utilization, but also how they're being matched to the infrastructure and which of those are actually associated costs directly to that pod. So that really gives you a lot of that chargeback, showback feature, really do real finite reporting back to the workloads that are running in different departments that you might have in different projects that you're running.
Great. Okay, Sebastian, so you talked a bit about some of the other options for storage services such as S3. So someone is asking, how much can they really save with archiving into S3?
That's the big question, isn't it? Well, okay, so let's put some numbers to that. So regular snapshots cost about 5 cents per gigabyte per month. Now, when I store that data, if I archive that snapshot into S3, then suddenly we're at about $0.023 per gigabyte. So it's about 2 cents. And then if you go one step higher and you're saying, well, I'm going to store it into infrequent access, then it's only about 1 cent per gigabyte per month. The only drawback with infrequent access is there is a 30-day commitment, which means I need to be sure that I'm probably going to archive this for longer than 30 days, because that's what's going to show up on your AWS bill. And then when I showed that little demo, and this was the sneak peek that we had with 2.7, you now also have the option to use intelligent tiering. Intelligent tiering in S3 is actually really smart. What it does is it almost has like artificial intelligence. It looks at how often are you using this data. In a very fluid manner, it moves the data between regular S3 and infrequent access. And it's almost like cheating, because when you're accessing infrequent access data, there is a retrieval fee of 1 cent per gigabyte. And that does not apply when you're using intelligent tiering. So that was a lot of numbers, and it almost sounded like we're doing a math test. Usually what you can say is, depending on which tiering you choose, we can literally cut that number of storage. What you're seeing right now in your AWS bill, we can cut that number in half. So even if you go with regular S3, the savings are about 60%. And if you go even higher into infrequent access or into intelligent tiering, you can ratchet that up to about 75%.
Nice. Okay. That's good news, definitely. Joey, someone has a question about Ocean Cluster support, supporting multiple AMIs.
Yes, it's a great question. So I briefly touched on the concept of launch specifications. And with that, in traditional sense, if you're trying to manage a varied cluster inside of a public cloud, for example in AWS, you would have to manage multiple auto-scaling groups individually, all managed underneath that Kubernetes cluster. Each of those would have specifications to specific AMIs, subnets, etc., for that particular set of pods that would be running on that ASG. Inside Ocean, we have intelligence and the ability to create individual and multiples of launch specifications that can handle individual AMIs, different node selector labels, taints, tolerations, etc., all within the same cluster. So you're no longer having to individually manage a multitude of ASGs and monitor those and how they're actually scaling. We set one set of rules for the entire cluster. We're working on expanding even more finite granular controls over each individual launch spec in terms of scaling and headroom. So those will be available soon. But right now, do all that definition in one place, get automated deployment and management of all of them together rather than having to separate those out into individual ASGs. So yes, we can handle multiple AMIs and other aspects even too within a single cluster.
Great. Okay, so I think we have time for one more. This one, Sebastian, we can touch on because I know a lot of organizations use identity providers. So someone is asking to log into your console, do you support SAML, SAML?
Oh, yeah, absolutely. That's a good question as well. So we don't have to use local users. If you have a single sign-on solution that supports SAML, ping, one login, or if you use Active Directory Federation services, absolutely, you can use that as well. It's going to work just absolutely seamlessly.
Awesome. Okay, so we're going to have to wrap up. Just a few points I wanted to touch on. So we covered two really great tools for AWS automation, and we really, really hope you enjoyed the presentation. Both N2WS and SpotInst have very easy to spin up free editions, which are fully featured. So all the aspects of the products that Sebastian and Joey talked about, and much more, can be accessed. So please, you'll get a link to that after the webinar in an email, and you can also click on the attachment and links tab over there. Please don't hesitate to reach out to us. You can either email me directly for N2WS questions or Joey on the SpotInst side. And also, we love feedback. You can there's a feedback tab where you can tell us, what topics you'd like to talk about, what other webinars you'd like to hear about. Specifically, we can deep dive into utilizing reserve instances, for example, serverless, building a CI/CD pipeline. Really, we'd love to hear your thoughts on that. And finally, we have very, very cool booths and prizes at reInvent if you'll be there. And we'd love to say hello. So please come by. Both companies have a booth there. And also, if you don't have a ticket, N2WS is running a promotion. We're giving away full conference passes plus an Amex gift card worth $1,000. So it just takes a quick form fill. Be sure to click on that link that you see over here. But last year we had a few winners, and they're still talking to us and thanking us because it was such an awesome trip, because it is, it's always fun in Vegas. So be sure to try your hand at that. And that's it. So we're really, really happy to have you join us. Sebastian and Joey, do you want to sign off?
Oh, absolutely. Thank you very much for joining us. It was a lot of fun.
Absolutely. Much obliged. To reinvent.
Bye, everyone.